Hi, everybody. My name is Tim Hawken. I'm a senior staff software engineer at Google. I've been at Google pushing 11 years. So I've taken an interesting tour through the Google stack from building hardware all the way up into building clusters. I now work on the Kubernetes project. I was one of the original software engineers on this project. And before that, I was working on Google's Borg project. So if you haven't read the Borg paper, you should totally go read that. I got a mention.
I'm probably the oddball here. So Jonathan Donaldson, I lead the software-defined infrastructure group at Intel. Prior to joining Intel, I helped start VCE, the vBlock guys, been NetApp, Cisco for 11 years, VMware, and now at Intel. So I kind of represent the enterprise use cases for some of this technology.
All right, Chris Kozirakis, I'm the director of research at Mesosphere, and I'm also on the faculty at Stanford. And I guess, oddly enough, I'm the hardware person here, right next to an Intel person. So I know a lot about what happens when the containers hit the iron, so I think that's why I'm here.
I get my own mic. That's why. So I'm Jared Rosoff, and I lead products at the 3-month-old cloud-native apps team at VMware, and spent the last 4 years at MongoDB helping people build really large applications, I think.
Cool. I'm Kelsey Hightower. I have a mic.
Apparently Kelsey's afraid of you.
Really? Yeah, no, this is my imaginary friend. Don't
That's Mr. Ed.
Yeah, Mr. whatever. All right, so I'm Kelsey Hightower, a product manager here at CoreOS. I still write code and build things. I'm a big supporter and advocate of Kubernetes and CoreOS, so go around the world and give talks about this stuff. My background is system administration, a lot of development, and spent some time at Puppet Labs. So I think I've seen this from the inside and the outside.
Well, great. Well, great to have you guys here. This is a great event, isn't it? CoreOS Fest. It's been a lot of fun so far. These panels have been terrific. Real good discussions. Really enjoyable. Great. And so I guess the question is, really, why are we here right now? Why are we discussing these new operations models for the future? Perhaps we can just start with that. Tim, can you discuss that perhaps a little bit about the context for our discussion today?
Why? Why this particular moment? I have no idea why this particular moment. I think something changed last year, the year before, and people, something clicked. Something clicked for people. They got it. Something that Google's been doing inside for a long time. It started to really gel.
Was that Docker?
Docker is what kicked it off, right?
But how did you see that in the user environment, like where you're starting to see people, actually doing this work? I mean, we read a lot about all these different types of changes, and we read about the developments that CoreOS is doing, that Docker's doing. But was there other evidence of the change that you were starting to see inside enterprise operations, or inside your own, what you're hearing from your own customers?
I'm not even sure where to go with that. Before this, I was purely internal to Google, right? My turn towards cloud and public products really was in response to this click, this audible click that everything suddenly turned overnight to be talking about containers and Docker, and I saw that we saw that as sort of an opportunity for places like Google to sort of say, hey, we know how to do this, right? This is our space. Welcome. It was exciting, and so why are people shifting to this? Why is this clicking for people? I think it's a natural model. I think that it makes a lot of sense, and I think that Docker did a great job of really nailing the simplicity of the model, of gluing the pieces together into something that works, and getting the ball rolling in a way that Google didn't. I mean, prior or around the same time as Docker came out, Google launched something called Let Me Contain That For You, which is sort of an alternate container stack. It's not intended to be the same thing that Docker is. It was really more of a demonstration of isolation. And not so much about images and formats. But Docker took it from an entirely different angle and really captured, I think, the imagination of a whole lot of developers and really got the snowball moving.
So I can take it from the business side of things, right? So I think there was kind of a collective sigh of relief 6-9 months ago for the developers, especially in the enterprise segment that really, really needed to start to have the velocity of application development that they're seeing in other spaces. And so from a strategic point of view for businesses, right, to be able to iterate on applications and iterate on these kind of strategic initiatives with the same speed as they're seeing in their cloud brethren, that's really the click for me was that 6 or 9 months ago when I said, aha, this is the way that we can go do it. And so I think that that's really one of the big drivers.
Okay.
I think from a technology point of view, there are two things here. On the one hand, containers, they allow you to pack a machine really, really well and keep track of isolation and really fine-grained resource usage. So that people that really want to get the highest possible utilization of the data center, they like this. At the same time, the same technology makes the life of developers easier. It solves the package and distribution problem. So the combination of these two got everybody to say, yeah, that makes sense, let's do it.
I think there's really two things I see. Number one, I think as software developers, I think we all sort of have a sense of the fact that the way we build distributed systems is kind of broken right now. That you'll design this application that's designed to run thousands of nodes, and yet when you send it to me to try it out, the first thing I do is like run through your README file to figure out like which processes to start with which port configurations and stuff like this, and I manually go set up this big distributed system, and you're like, hold on, I can like spawn threads programmatically, like why can't I spawn my application programmatically? And then on the other side, you've got these folks in operations who largely have been like sort of behind a firewall from the software developers, and they're saying like, hold on a second, like you can't run this system. This doesn't have any security controls. It doesn't have encryption. It doesn't have like any way for me to capacity plan for it or anything like this. And I think that we're seeing like a real merging of these two things, that we need to have the operational systems that the teams use to run these platforms need to become part of the applications that we're actually developing.
So your question is like, why are we here? And I've been very close to the actual, like, on the ground.
Yeah.
And you can see this thing bubbling up. I think most people, especially where most people are at. So the thing about where we are today, it wasn't led by all the innovative companies that have been doing this for a long time. They didn't kick this off, right? They let it happen from a grassroots era. And it came up from the grassroots because I think most people on the ground push their current infrastructure to the limit. Like most people have some form of configuration management. They've taken that configuration management all the way to the edge where they wrote a bunch of infrastructure as code, they're deploying apps, but that doesn't really scale well, right? You have all this code that now you have to manage the code itself. You get to the point where you onboard a new team member, you have to teach them Puppet or Chef or Ansible just to get them started, and you still have this gap in communication between an application developer and what someone has to go and codify into your configuration management system. So I think there's a bit of a frustration that boiled over. Right? So most people have to take technology based on where they're at. So if you're already in the configuration management world, you can't just pivot to Google scale infrastructure day one. You see it, and you look at it, and it's like, wow, there's a lot there, and there's this one piece that we can actually take without redoing everything. And that one piece, for most people, has been containers. You can bring that in and integrate it with the rest of the things that you have, or do the whole shadow IT thing where you just say, we no longer use configuration management to deploy code. We just set up our servers with it, and we can kind of just deploy code instead of using something like these out-of-band scripting tools. You can just use the Docker API. And I think that has been the ramp up to where we are today that gave enough momentum to have other people jump into the party and offer the rest of the stack.
Yeah, I think to dovetail into that, I think that the major reason that we're here today is because it's necessary, right? You've looked through the computing roadmap year after year after year, and every once in a while there's either an evolutionary or a revolutionary jump that takes you to that next step, and this is one of those, right? So we've been kind of held back by what the capabilities in the data center are. We've seen others like Google that can actually go do the things that the rest of us would like to go do, and so this kind of for the masses type of push is the next step that's necessary to get us on that next wave of innovation.
So Jared, what kind of questions are you getting from your customers about this shift? I mean, you guys have been the virtualization kings for a long time, and now we're talking about containers, which is a real change in thinking. It's forcing a lot of people to think differently about their own environments. What kind of questions are you getting from people that that illustrate this shift?
I think a lot of people are just trying to figure out what it looks like in an end state. I mean,
what do you mean? Like, okay.
Well, so if I look at the average data center today, not like I wouldn't classify like Google as the average data center. That's I think what people are trying to get to. It's largely I have a lot of operational tooling there. I can be able to do things like governance and security management. I can go and audit all of my systems and tell you how many licenses of SharePoint I need to pay for and things like that. And I think that one of the things that happens is a lot of these operations and administration teams are trying to figure out, well, what's my role in this future where a lot of the software we're running is not packaged software, but a software that was built by my own software development team. I'm not like installing something that's commercially supported from Microsoft. I'm running something that my own engineers built. And how do I get the same level of robust sort of controls over what's being used in my data center and how resources are allocated and what the SLAs are when that's not like a built-in feature of the code that I'm getting. So people are trying to figure out like how do I get that same level of control over the things running in my data center in this new world of software that was written ourselves.
Why? So that level of control that they're asking about, are you guys getting these questions? Anyone here else about that level of control that they want?
So just to tie it up on one comment that was said earlier. So I think it's still difficult to write distributed systems even with containers. It's even more difficult if you don't know how to isolate your executables, you don't know how to package the application. But there are many hard problems about running applications with tens of thousands of anything and making sure that they're correct and fault tolerant and so on. So I think there's still a huge amount of questions, but exactly the same, whether you start with process, with containers or VMs, and we have to figure them out for containers. Containers make life, the starting point, much, much, much easier. So I don't think there's going to be any shortage of questions that people are going to ask about any of this technology.
So, we're here today and we're talking about this application container spec this morning, and it's coming on pretty fast and furious. And we talked a little bit this morning about why we're at this point right now. But I guess I wonder really what is the importance of it at this point in time, and why people should be caring about this new spec.
I think regarding point in time, first you build a prototype, and you run the prototype right up to the edge, and then the whole thing starts to shake a little bit, and then you go back and you figure out what you just did, right? And I think that's where we are. And I don't mean to call Docker a prototype, but like of an ecosystem, they prototyped it, right? They showed us what's possible, what we can build. People got on board, they got in the mindset, and now it's time to go back and make sure that the house is built on a solid foundation. I mean, I keep using the foundation analogy, but it's really, I think, pretty apt. Like, you cannot build up unless you're solid at the bottom, right?
And I would tackle it from about the same direction, but maybe a slightly different spin. So if you look at what containers are meant to go do, right, which is taking an application or a microservice and packaging it so you can put it into one of these distributed systems. Portability is key. So having a standard, right, that is widely adopted so you can do portability. Programmatically being able to change and configure what that container is and what it attaches to. Applying networking to it, applying storage resources, applying security resources to it. If I have to go solve that problem 4 different ways for 4 different types of containers, that becomes technical debt that we just don't necessarily need and kind of slows down the adoption.
So at CoreOS, we're kind of leading the charge on the application container spec. So we kind of kicked it off, and now we have other members in the community driving it. But I think you have to ask the question like who you are, what side of the coin are you on. Some private institutions have no need for the spec at all. They don't really care about necessarily sharing or interoperating with anyone else. They understand the Linux technologies themselves. They'll build their own platforms on top and be happily ever after. I think now that we are in this world of people consuming other people's machines and infrastructure, AKA the cloud, you kind of want some specification like what should I build for, right? If I'm going to build this artifact, how do I know it's going to run on your platform and your platform? And one way of doing that for some people is having a spec. So I don't think it's an either or thing. I think for the non-builders of cloud infrastructure, they just need a spec to write to and they'll do their thing. And then for the rest of the people, they may just be happy knowing that the technology exists and they can go and innovate and reimagine things that may be outside the spec. So I don't want to limit anyone's imagination by saying, here's a spec, now we can all stop thinking. It's just checkpoints in time, like you said with the moving from the prototype.
And I think that the community and the ecosystem is an important part of this, right? I think that, you know, in the past when we had proprietary platforms, you know, you go off and, you know, with VMware, we built a hypervisor and we had to build a whole ecosystem of management tools that went up around it, but we were the only ones that really could see how things worked on the inside and how all those tools pull together. And you know, I think the big shift with open source and community-based projects is that, you know, it's not just one company driving this. There's networking startups that are putting networking in containers. There's security startups trying to put encryption and authorization into containers. There's orchestration tools like Kubernetes trying to layer on top of this. And so we all kind of share these standards, and we all need to kind of participate together in figuring out how it evolves so it's a platform that we can all co-innovate on.
Let me just turn this back around on it for a second, right? So we use a shipping container, right, as the standard for what we talk about in containers. How efficient would that logistics system be if they all had different lengths, widths, and depths, right? You'd have to retool cranes, you have to retool trucks. It just would not be the efficiency that we're looking for. So we absolutely need the standards to be there.
Also, openness and competition is a good thing. I don't know of any industry where you had one thing blessed from the very beginning and everything worked out really well. So it's really nice to have multiple, you know, container definitions and multiple network solutions, storage solutions, and security. You know, it's going to take a while to get, you know, all the great technologies out there, and this will accelerate it, for sure.
So what are some of the conceptual changes that, you know, people need to start thinking about, you know, as they think about these new types of data centers? The one thing that, you know, I hear more about is just this application-centric, you know, universe that we're in. And, you know, Adrian Cockcroft talks a lot about compute patterns, for example, and talks about how, you know, now we're just dealing with hosts and the containers are running on the hosts, and essentially, you know, now we're dealing with all these kind of issues related, you know, related to data gravity and, you know, and how do you, you know, how you design kind of these infrastructures around that. And because there's so much more data out there that people have to deal with, you know, what are some conceptual frameworks that you guys think about when you're thinking about all these types of different issues?
I'll start at the low level. Like, a lot of people have been just kicking the can down the road as far as how they build applications, right? Like, maybe you started building applications in like the late 2000s, and then most of the technologies that have been coming out to manage this stuff just allowed you to kick the can down the road, right? So like virtualization, don't change anything, virtualize it, and you can just kick the can down the road. Configuration management, don't change anything, we can just build these tools around it and it can just remain the same. But eventually you just run out of steam here. And at some point you're gonna have to address your application and the way it handles fault tolerance to actually exist in the world where I can take your app and deploy it anywhere, not live migrate it anywhere and take all the state with it, but literally fire it up somewhere else. You're just gonna have to eventually just bite that bullet and pay back that technical debt.
So look, this is not the first time that we're dealing with this thing. If you look at supercomputing, they've already learned it. Every time you want to raise the scale by a factor of 10, you typically have to rethink your infrastructure. So this is what we're stumbling on as well, where people start an application where they're thinking that, you know, 5 friends will use it, but in a year I would like 10 million people to use it, and, you know, in another couple of years, you know, billions of people to use it. So the question now becomes, how do you help people to write an application in a way that it will scale as their company or their site does? And this is where, you know, we're all trying to build infrastructure to make it as automatic, as painless as possible. It will never be completely trivial, but make it a little bit easier than it is today, which is write it once every couple of years, rewrite it every couple of years.
I think one of the, people talk about the sort of pets versus cattle analogy. And they talk about how, you know, when you start to have like thousands or millions of these things running in your data center, you can no longer keep track of each individual one. But one of the things that happens in that transition, that's largely correct, right? But the thing is that your pets haven't gone away, right? You still have your mobile app, and it might be made up of hundreds of thousands of containers running across your data center, and every one of those containers could live or die or have some different life cycle. But your notion of your mobile app still exists. And so if your infrastructure is just keeping track of the cattle, right, where does your pet exist? Like, it's still there somewhere. It's a much more ephemeral thing because it doesn't map onto like one thing running inside your data center. And I think that's, like, to your point, we're not trying to pile something around some crufty thing that just works around the pattern. We're trying to like figure out like what is the right separation of like the logical concept of my mobile application versus the like physical reality of the hundreds of thousands of compute, network, and storage resources that manifest that application.
And I'll give you a concrete example. Like I'll meet people that are new to like distributed systems in general. And one nice thing that now a lot of people are starting to share is some of the patterns for doing this. So I asked the developer, why does the sysadmins have to start your app in a certain order? Like start the database, then the app. And we built a lot of tools. People laugh because we've built so much engineering time has been spent around starting things in the right order. And it's simple. Like imagine if you start your web app and it just checked to see if the database was there. It didn't segfault. It didn't reboot the whole server. It just kindly logged that the database isn't there. I'm trying to connect to that IP address with these credentials, and it's not working. And I'm just going to chill out until that shows up. Then just doing that alone, you kind of move the ball forward a little bit. Now no one has to order how we start these applications. We can start them both up at the same time. We can actually do maintenance without crashing the whole world. So there's little small techniques like this, I think, are in the details that move outside of containers that prep our applications for actually running in a distributed environment.
All right, go ahead, then I'd like to see if the audience has some questions.
No, I was just going to say it'd be fun to read his code. I'm just going to chill until the database comes up.
Yeah, I do have a chill logging package. It's awesome.
Is that how you do things at Google? You just kind of chill?
That's entirely Kelsey's domain.
What's Google's domain then?
Google's domain is very boring. We're not very exciting with our commentary as we write our code, unfortunately.
So you're saying Google doesn't know how to chill?
I would say that yes, the people I work with are not very good at chilling.
Well, what do they do? Like, how do you guys manage your cattle? Do you treat them as cattle or as pets, or do you not even care about those analogies?
It's a fair question. I mean, the classic point in the pets cattle analogy is, your pets have names and you take care of them and you know them by name, and your cattle have numbers, right? And if you've got 5 servers, they might be named, Happy, Sleepy, Dopey, Grumpy, and Doc.
That's
right?
very good.
But I can't do all 7. But if you have 10,000 servers or 100,000 servers, they're suddenly named XYZ123, XYZ124, XYZ125, and I do not know or care where my job is running, right? They are all fungible. They might all be different bits of hardware. They might have different classes of CPU, different amounts of memory, different size disks, whatever. But I've written my job in a way that says, these are the constraints that I need you to satisfy. Please go forth and satisfy, right? And so to that end, when XYZ124 dies, all the jobs on it get moved and they get spread around to the rest of the XYZ rack. And nobody really cares, and right? We just put a bullet in the cattle and we send a tech out to, birth a new cattle.
How did that come back to the point where you are, where you just don't care? Is it just because you've had to scale tremendously? And
you can't care at scale. I mean, there's not enough human bandwidth in all of Google to take care of the number of machines that crash in a year, right? If we sent, if people had to run around in a panic every time a machine died, there would literally be a fire like constantly, because we have some small percentage of machines that are dead every day, right? I mean, all these disks, all these machines, they have spinning disks, and spinning disks fail at an enormously alarming rate. So every day there are techs out there with scooters and trays and carts pushing out to repair stuff. You just cannot care enough about those machines. You can't care too little about those machines, because if you care, you're going to do the wrong things.
So I think your question was like, how do we get there? And I worked at Google for a short period and can attest to what he's saying is that Google spends a lot of time investing in actually improving things, right? When you meet a Google SRE, this is like sysadmin on steroids, right? Because people actually analyze data, look at that data, and build new tools to actually make all this possible. So it's not going to happen overnight, like, hey, we're just going to start moving to this model. You actually have to have people that have time to actually think. It can't be a fire drill all day long. You can't patch it up with a DevOps Band-Aid.
But that's their business, right? I mean, they're scaling applications all the time. They've got, I don't know, untold numbers of users out there. It makes sense for them to build those tools, right? So, it makes sense for them to analyze that data.
So, I mean, it's important to draw the line between the 2 parts of this conversation. There's the part about like running the clusters and running the machines and taking care of that, right? And we run like the entire Google fleet on 2 digits worth of people in our SRE team. Our Borg SRE team, I think, is on the order of 20 people, right? And they run the entire damn fleet. And they do an amazing job of it. But it's because, as Kelsey said, every time something goes wrong, they write a tool. They write some automation. They write a playbook that says this is what happens when you get this sort of alert. And they are rigorous about that. And they are serious about what they do. And then there's the hundreds of application SREs, and they're off running the applications. And they run Gmail, and they run search, and they run calendar, and they know where it's going to fail and where it's going to scale. And the two groups of SREs, they're not the same group, right? They're not the same people, because that doesn't scale. You can't make your devs run your machines at scale. There's just not enough brain bandwidth.
So
there are certain things that get harder as you try this thing. For example, like most of the people that I know that took the application and moved it to a shared environment of any kind, the first thing they realize is that their performance is all over the place. Because suddenly you used to always rely, you got 2 cores and sometimes you don't, because there's not enough of them, or today you got the good cores and tomorrow you get the old cores, and you start seeing variability, and developing tools to catch these things and ways of expressing constraints so you can automate some of these things. It's actually kind of difficult, and this is part of what is the infrastructure we try to develop. It's not just, here's a container, launch it someplace. Also being able to reason about, here's how 1,000 containers go back to a meaningful application with some performance guarantees or some availability guarantees.
Before we step away, I think that's a very important point to make, right? That is the gold here, right? So you said, Google, you have this amazing set of SREs that analyze data, make things better, right? That's the gold here, right? If we do Kubernetes correctly, if we do containers correctly, if we do things like CoreOS correctly, we get closer and closer to their type of infrastructure without having to have the fleets of PhDs.
By building all the tools in.
By leveraging the knowledge base that they're handing out and working with the rest of the community to deliver, by all the other technical innovations that are happening around that community, that is actually going to democratize and deliver that style of computing and all the benefits that they get to it to the masses.
So is there anyone who has any questions? I mean, these people are like as smart as they get about this kind of stuff. Do you have any questions you guys have about this new world? Anyone? I'll buy a cup of coffee if you ask a question. What's that? Oh, we have one over here.
Give us something controversial. That's right.
There you go.
If you're at one internal Google technology to Tectonic, so we have Giphy for everyone, what would it be?
The question was if I could take one internal Google technology and add it to Tectonic. Wow. One single piece, huh? I mean, I think that one of the things that makes Google really strong is the deep integration that we've got, which is not, I'm sort of avoiding the question here. The fact that we control sort of everything from the code up means that we can do things in a really highly integrated way that are really powerful. And it's not true with open source. I can't tell you to go out and rewrite your web app to use Google's RPC system because the Google RPC system happens to be instrumented properly. But I think the things that internal to Google that I want to see more of out in the world are informational. They're things like the monitoring, alerting, logging, dashboards, info sessions. If you've read the board paper, I was just speaking with somebody beforehand about the Sigma project inside Google, which is this massively dense data view of what's happening in your cluster. And I think this is the place where we're going to need a lot of work.
I want that and Dremel on top.
If there was a suggestion box at the front door of Google, I would put in networking from my side.
I think, honestly, the #1 thing is that Google has this huge advantage with their distributed file system that, you know what, most people can't even get started with this platform because they don't have apps that know how to deal with their data. Like if you're dealing with MySQL or Postgres today, it's going to be a huge amount of work to try to get that to coordinate itself in a system like this. But when you start to have like a reliable distributed file system that can replicate and is geo-aware, it just changes the game for tools you build like no other. And I think that's like one key technology that we're missing in the open source space.
Do you really think that we should tell people to rewrite everything before they get to play in this environment. I think we should just make it easy to, keep some of the old stuff for a while, start running, and when you realize that, your favorite database doesn't work anymore, switch to that better.
You see that right there? That's the can. You're going to run out of steam. And I think we're getting to the point now where there's enough momentum where people are gathering the courage to rewrite these systems. We see it all the time now. Like people are writing these new stores that are cluster aware. They're immature. They're not necessarily going to match maturity, but you got to start somewhere to get there eventually. And I think we should allow that momentum to continue and keep it moving.
I have no objection to having people do better stuff, but the thing that neither Google got to where they are in one day, or they started selling services before they got there, or VMware, or anyone. Like I think, pragmatically speaking, you have to accommodate people moving the more urgent parts first, and slowly catching up with the rest of them. It's a little bit of arrogant to go and say, no, write everything the Google way, and then it's going to run really, really great.
So, I mean, we all like to make fun of MySQL, but the fact is it's massively successful and massively widely deployed, right? Yes, everybody who uses MySQL should rewrite their application to use a cloud-native storage system eventually. We went into Kubernetes with the foundational assumption that we can't ask people to rewrite their applications. We have to give them a path forward that involves taking a series of discrete steps. We can't ask them to sort of jump over the Grand Canyon.
So to clarify, there's a bunch of startups that have the freedom to not support existing things. So I think in our ecosystem, when you talk about the whole ecosystem, we have to have a slice of that ecosystem that doesn't have the bondage, right? One that says, you know what? You do not have to support existing enterprises, even though you may go out of business in 4 years. But we need you to think freely, because without being able to think freely, it slows down the momentum. And I'm not saying all this stuff is going to be wildly successful. We need a slice that can be free to experiment without necessarily having to support every decision and mistake we've made in the past.
Yeah. Frankly, woe be on the company that starts a new product based on MySQL.
Wow. No love for MySQL up here. So I would say, the best thing to do is make it so attractive for individual developers and for companies to follow this path that they will be pulled naturally, right? If you try and force them by shoving them off a cliff, you're just going to get pushed back, right? What do people do when they get up to the edge of a cliff? They're going to push back, right? The idea is to make it so attractive to go down the path with you that they'll naturally do that.
Yeah, I'm talking about highlighting the open sign. Like there's multiple paths, and you have to turn on that sign to say there's another one. It may not be for you, but we got to kind of light that trail a little bit to start that conversation. Even though most people can't adopt this stuff in production, we got to get more people into the conversation to speed up the adoption of some of this new stuff that may be thinking a little bit outside of the box.
So I think that the speeding up is a great phrase, because I think that much of what we're talking about today is like, one, for application developers, you're trying to help people build software more quickly, build applications they couldn't build before. And for operations teams, you're trying to help take, an operations person that manages 100 computers to your Google SRE that manages tens of thousands. I don't want to guess what the number is now. And sometimes the fastest way there is actually to not throw away what you've already got, right? That if don't ask me to recreate everything I've already created in order to adopt this new technology. And this is a very common theme we see. I mean, a lot of our customers are running 20,000 applications as virtual machines, right? And so walking in and saying, just rewrite all of these as containers, like, well, that's not agile. That's like the opposite of it. That's like a bunch of work that's going to yield no near-term value.
So we're talking about like the newer companies. So there's like new companies that were started in the last 8 months, right? And these new companies have the ability to leapfrog their predecessors by years by just not having the legacy to deal with. This doesn't work for everyone. I'm not saying you go to the typical enterprise and have this conversation. I'm actually being pragmatic. If you're starting a brand new company, there's some technologies that have come out in the last 2 years. If you're willing to investigate those technologies, you can use some of those technologies to leapfrog the game. So you have a couple.
We're already seeing examples of that.
You see examples, like you have a choice. You can go out and build RPMs, DEBs for all your applications, or you can skip that step and maybe pick one of these container runtimes and go that path. And for a lot of people, it is true. It is actually working for them. So I'm thinking that we need a little bit of focus in all the areas. But for me, I'm kind of excited that we actually get that freedom a little bit. Just for those new companies that are willing to say, well, we don't really have any legacy stuff. We want to talk about what should we do, and we kind of help grow the number of tools where the new companies that are coming on board and coming alive now and next year, that they have something new that they can adopt and bring in. Our job is to bring that technology to maturity much faster than waiting before we can make it work for the existing enterprise.
So, as much as I agree with what you're saying, I think that there's still issues. So even if you write everything from scratch, just scale brings up different issues. So if you try to write something for 100 users, 100,000, a million, a billion, what have you, there are different choices, even if you write everything from scratch. Like ask Googlers, they didn't write a single database that scales. They wrote one for data center scale and then another one to cross across data centers, and they were quite different. Okay, so I don't think that it's easy to go and say, yeah, you rewrite once and it's going to be perfect from the very beginning. People will bring some old stuff, they'll write some new stuff, they'll fail with the new stuff, they'll kill the old stuff. It's going to be continuous evolution, and we need to make sure that all these things can coexist. We don't have to force everybody to switch everything at the same time.
And I'll push back a little bit on the perception of the enterprise, right? So it's not just the new companies that need to do this, right? And it's not just the new companies that are going to do this. It's the legacy enterprise companies that are also doing this, right? They need to be competitive. They need to be strategic. They're not sitting there spending a tremendous amount of effort rewriting legacy applications. What they're actually doing is writing the new things that are going to actually get them that strategic benefit. And so they're just as much on this journey as we are.
What are you seeing them do? What are some of the use cases where they're, for instance, using containers?
So I would say a lot of it is where they are entering the kind of the new world for them, right? So they're having to hire in net new developers or develop new skill sets internally to deal with the mobile app market, or deal with kind of the business-to-business type of thing where they're doing API type transactions back and forth for everything from just-in-time ordering to you name it, right? So it's those types of applications where before they've never had to scale. Right, so if you're just doing 1 to 5, let's say, suppliers, there's only so much scale you need to do with that, right? But if now your just-in-time ordering or just-in-time manufacturing pulls from 500 suppliers or 5,000 suppliers, that's a very, very different type of interaction. And so they're having to develop new skill sets or hire new and build this way.
So why should they even have to do that? I mean, shouldn't that middle tier be the responsibility of a platform provider?
So it depends upon what you believe. So if you are a manufacturer, are you willing to place the success of your business and your customer satisfaction in the hands of somebody who maybe or may not have lived a day in the life of whatever your business is? Each company has different types of transactions. They have different things that mean something to them. They have different things that are, gatekeepers to their success. And you're not going to find many companies. I think it was you, Jared, that mentioned control. Right? Most companies are very unwilling to give up control of the things that make their business successful.
I guess so.
Absolutely. Yeah. Now, that control can be in many different ways, but I think that you're going to find that most of them want to develop their own systems to handle that.
So I think there's a timeline too, right? Like, I guess people care about a lot of things that they think they want to care about. Like most even larger scale companies don't really care about building their own power grid. They kind of just pay the power bill. ISPs, you're in a data center. You get a few choices on who's going to bring in that bandwidth, so you stop caring a little bit because it's been working, it's mature. And I think as the timeline moves on, there's going to be less and less things that you just really, really want to care about. Like, I'm not saying everyone's going to move over to a certain thing, but the fact is it's actually here. Like, we're in an era now where there's a lot of technology that a lot of these large enterprises that want control don't even talk about anymore. They just pay the bill. So we'll see where that timeline takes us.
Control moves. Right, to the things that they, at the end of the day, that distill down that is core to their business.
It seems arguable that the whole middle tier will start to go away, and you'll just have these platform providers.
Yeah, but then we have to be careful about one thing. If everybody only cares about using some prepackaged applications, the audience for all this container stuff is the 3 developers of this application, Salesforce.org, .com, and whoever else is doing this. I think that there's very interesting stuff because there's many companies who don't see exactly what they want being offered, the software as a service, and they have to do software development either because they believe they bring up some value, or there's some new technology they bring to the table. And I think this is the kind of companies that you want to actually motivate to develop the new analytics, the new middle tier, the new whatever. So we cannot just assume that the middle tier will happen on its own. Somebody has to develop it, and that's what we're talking about.
Yeah, and I think that a lot of the innovation, the place where people are adopting these new technologies, is really being driven by competition from new software companies against brick and mortar, right? If you were a cab company, all of a sudden Uber's your competitor. If you were a local retailer, all of a sudden Amazon's your competitor. And what we find is that like almost every business needs to become a software business in order to be able to compete in its segment. And so, the question is, if you're a sort of very stodgy old, brick and mortar company, and you're trying to go compete with the user expectation that's being set by Uber, right? Like, you're going to need everything that you've got to play as an advantage,
So
and that's going to include.
It seems that's the driver. Like the application development is the driver here.
It's very hard to compete with the scale and the margin that being a software-enabled business gives you.
Well, I mean, you have a choice now, right? Like, you don't necessarily have to call a big vendor and have a conversation for a year before you can get started, right?
Yeah.
Most of these systems, like, do you have a credit card? You can kind of get started. You don't necessarily have to have permission.
Or you can just go.
You can use open source. We're getting to the point now where I think Google has said this as well. Kubernetes had to be open source. Like, people are not willing, in the future, you guys can draw your own timelines, that we don't want to build everything on proprietary stuff anymore. It cost us a lot when we did that before.
Yeah, we're gonna need to wind up here. We've gone over our time,
Cool.
so thank you guys very much for being here, and thank you all for listening in.